We are going to see how to use the HFSS practically. First, double click on ANSYS Electronic Desktop. So now you are seeing here, it is going to open Electromagnetic Suits 19.1 and the Electronics Desktop version 2018.1. It is from ANSYS. It is going to open. Now see, you are getting the ANSYS Electronic Desktop Project 1. Okay, now we didn't allocate any particular name. Just now it is open. So now what I'm going to do is, we are just going to design HFSS software. We are going to use HFSS software to design the microstrip patch antenna of 5.2 gigahertz. So for that, just go and click HFSS. And here you can see you are having lots of options, different options. You have to select HFSS from that. So once you are selecting the HFSS, now you will get the proper screen where you can draw your or you can model your antenna. So this is normal. You are having all the menu driven spaces and all. In the left hand side, you are having project manager. Since still now I didn't assign any name, so it is showing as project 1 star. It is not yet saved, so it is star. Then you are having different properties at the bottom corner of left hand side. Then you are having the coordinate system part, and this is your space area where you are going to design your antenna. And here you are having few different components. Suppose anybody want to model or want to get the help of library, and based on that want to design something, you will have some component parts here. So now we are going to go for HFSS. Then you select solution type. So as the solution type, you just select the solution type. Next, after selecting the solution type, from here you are getting solution type. So here you are having modal, terminal and other so many things. So here from you have to select the terminal, and you will be as it is in network analysis. Then press OK. Okay, so this is the solution type through which you are going to design this particular model. So okay. Next we'll go for the modeler. So where we are going for the modeler, so there we are going to set the units. So this full design you want to make, see here, if you are seeing here, lots of different units are there. Meter, mil, and then you are having in nanometer, picometer, so many things are there. From there we are going to select the millimeter. Okay, so millimeter and then select OK. Now we have set our unit system. Next we are going for the draw part. So go draw. Now we are going to start designing the particular antenna. Okay, since this antenna having some particular thickness, so first we are going to take a 3D part, and for selecting the 3D part we are taking the box. Okay, so you just select the box. So then and there you are selecting the box. You just see for your left hand side you are getting some measure data part. Now you come to your workspace, and there anywhere at the middle you just click, or otherwise if you directly want to enter your position, so directly you can enter from here. See here I am taking my mouse, so there you can select your design your X position, you can put your Y position as well as your Z position. Okay, that is also correct. Or otherwise what you can do, you just fix anywhere and click it. Okay, so after clicking, since it's a box, it's a 3D space, you just take any dimension and click the box. Okay, if you're clicking, then it will come for this particular, it will ask you for the position and all. Now what I'm doing, I'm just giving that particular box position. Okay, so these are all pre-calculated things and all. So what I've already shown you in the design. So in the position part, just come here and just click. Okay, so we are just putting the position minus 17.95 as calculated before, then 0 comma minus 1.6. Now what will be your X position, because it's a 3D model, so therefore you are having both X, Y and Z, all X, Y and Z. 35.9 is your X position. Then your Y position is 58.94 and your Z position is 1.6. That is the thickness. Okay. So now what you have to do? Now you just make it apply and okay. Okay. Now is it clear? Okay. Now what you have to do? Now see, your box is not visible. So to visible the box inside the screen, you go here and put fit all. So fit all is the contents in the view. So I'm getting fit all. Okay, now what I'm doing, I don't know like what is this particular box actually. So you have to go for to give its name. Okay, so you come here and just select double click the box. So what will happen here, you will get the name. So okay, so in place of name you just put the word sub. So okay, this is sub, and this is the substrate where I have to fix the material also. Okay, you know, for any kind of substrate we have to give the material also. So what will the material? You just come for the material part, you select, then in at bottom you will see the edit option. So you go for the edit, then one new screen will open where you will get n number of material. So here we are using the FR4 epoxy. So you just search here for FR4. Just click it here. So you will see that FR4 epoxy, and that is the material with relative permittivity, that is 4.4, which one previously I have shown you in the example for calculation. Now what you have to do, just you put OK. Okay, now see here the color selection and all in your choice, because color if you select them you will have some kind of identification part. Then select any color, then put OK. Then this is the transparency part. So how much big transparent part you want to see. So based on that you just select your transparency. That is also your own choice. Whatever transparency you like you can do it. Then apply and OK. This is your optional part. Okay. So next what we have to go? We have to go for draw. So next again, now my substrate is ready. Now what I am going to do? I am going to design the rectangular patch. Okay. So now again I am going for draw. Then I am going for the rectangle. Okay. So again like previous, you position anywhere. Okay, and click it, or otherwise like I have shown you, like here also you can make it. And here since rectangle is a 2D part, so therefore for rectangle you don't have any kind of Z direction. So just anywhere you just plot it and you just draw one rectangle. So immediately you have drawn the rectangle. So what will happen? It will ask you for the position as well as it will ask you for the coordinates. So just click there, you just fix the position 8.78. These are all calculated previously. Then you will have 23.19 and you will have 0 position. Then you will have, since 2D, your x-axis, z-axis, you see it's a fixed one. You will not have any value. And already you have designed the patch. So that patch value, dimension, you just give here. That is x and it is your y, 12.56. So everything is here in the millimeter scale. Okay. So apply and give OK. So now see, perfectly your patch is positioned in one area. Now what you have to do? You have to go and select the particular rectangle, and here you just change the name. Where I am changing the name means, if everybody is telling that one as a rectangle 1, rectangle 2, so it will be very difficult to identify that what is what. So afterwards, when you are coming for the solution, that time it will be so difficult. So therefore I am selected as patch. Then you select the color. So that color, that is as per your choice. Whatever color you like you can choose, and you can put the transparency also as per your choice. That is again I am telling, it's optional. If you like to do you can do, or otherwise you can leave it. That's all. Okay, now my patch is ready. Now what I have to do, I have to go for different kind of now I'll go for the ground plane. Okay, so for designing the ground plane, again it is, what will happen, it is back side of the substrate. So therefore again you go for draw and you select the rectangle. Then again the same way, just anywhere you click and you just make the rectangle ready. Now again the box will open. So there you just position your particular position for the ground plane. So it will be minus 17.95 comma 0 comma minus 1.6. Okay, so that is your position of the ground plane. So here you write the x part as 35.9, same as previous substrate, and here you will have the 58.94. Okay, so this is the design for your ground, coordinate system for your ground. Then you apply and then you put OK. Okay, then again you are seeing that this is also showing as a rectangle. So we have to specify this. So again we are just taking it as a ground, O-U-N-D, ground. Okay, and here also transparency, you can make anything and you can choose the color also. So choose any particular color and set OK, and you can set the transparency also as any particular transparency. So as per your choice, you just choose the transparency and put apply and OK. Okay, so now what all I have set? I have set the substrate with some height, then I have set my ground plane and I have set the patch. Now what I have to do? Now I have to come for the different. This is the like H feed type. So therefore we have to give the feed lines, and this feed line also definitely it will be a 2D structure. So definitely again we have to go to draw and we have to select the rectangle again. Okay, so anywhere you just click it and you just put the rectangle, and finally you give the dimension. So again the position is coming. So the position is as per previous calculation minus 1.5295 comma 14.896 comma 0. Okay, and what will be your X position? Your X position will be 3.059 and your Y position will be minus 14.896. Okay, these are all, as repeatedly I am telling, these are all you have calculated previously. Now you just apply and OK. Now you see that perfectly this feed line is created. Now what you have to do, again we have to change the rectangle name, and since it is a feed line, so we are writing it like a feed line. So if you are giving proper name, so finally you can identify that which the things, what all the things you have done before. Okay, then again you click here and you select any some color here again. Why I am defining the colors means it will help us to identify which particular things we have designed based on the color. Okay, so again I have done the transparency, again it is done. Okay, now my feed line is ready. Now what I have to do, I have to go for the edge feed. Okay, this particular part we have to design. If you want like fully you can feed same way. Why I am doing this is a 50 ohms line. So to make it compatible we are designing in such a way. Okay, so draw, again you go for the rectangle. So again you draw the rectangle here. Now what I am going to do, I am going to go for the edge feed part. So for the edge feed, again you select your position. Your position will be minus 0.3615. Then you will have 23.19 and then 0. Okay. Then we are coming for the X position. So my X position is coming as 0.723, 0.723, and your Y position is coming as minus 8.294, 8.294. Okay, so apply and you just keep it okay. Now again, as per requirement, we are just taking the edge feed and we are just giving the name as edge feed. Okay, now what you are going to give, you are just again going to give the color. Okay, then whatever color you like to give, you just place the color, and here you just place the transparency as per your choice. Okay, so you just put apply and then okay. So now see here our full structure is ready. Now the thing is your H feed is ready, your feed line is ready, your patch is ready, along with that your substrate is ready, and along with that you are having the ground plane also ready. Now what I am going to do, I am just going to give the same character for your H feed, your feed line along with the patch. So what I am doing, I am pressing the control, then H feed is already selected, just take the control, then put select the feed line and as well as select the patch. Okay, so all these three select together, you have to select and click the right button and go for the edit, then go for the boolean and go for unite. Okay, now see here one unite button is generated. If you are extending that, you will see that under the H feed, since H feed you have select first, so under the H feed your feed line and patch came together. So previously if you have seen means it is not like came together, now it is combined together. Okay, so that is the thing we have covered unite pattern. Now select the edge feed and ground feed by ground by control. So now what I am going to do, now I am going to select my edge feed and again like my ground together, And what I am going to do, again I am giving the right click. Okay, then I am going for the assign boundary, and after assigning the boundary I am going for perfect T. So it's electrical fill, so perfect T we are choosing. Okay, so here it is showing as perfect boundary type. They want some name, so it is perfect E1. Okay, so then you put OK. Okay, it is selected. Okay, now the first part of the things are completed. Now what we have to do is we have to go for the pattern for radiation. So you know that if you're just giving one bound, now it is an infinite boundary part. Now if you design some kind of box, I mean boundary part, then only this particular reflection and all pattern you will get properly. So therefore, since you know that box is a 3D pattern, so they will go for draw, and we are going for the box. And again you draw anywhere that particular box, and finally we'll just give the position. So again we are coming for the position part, and here minus 32.37 comma, then minus 14.32 comma, and minus 16.02. So I have shown you all the calculation part previously step by step. So based on that only now you are selecting the position 64.74. There is other choice also you can do by that also. I'll tell you how to do. So this is one of the method. So if your calculation is fully ready, so you can go for very easily with this particular pattern. Okay, so now it is apply and it is okay. Now again you are seeing that it is not fitting, so you have to go fit all. Okay, now you see that your boundary also ready. Now again you select this box and verify, then give that box the name as rad. So it's a radiation pattern, so give it as rad. And what you have to do is just select your color. That too also I told you repeatedly, it's a choice, and just put it okay, and you just put it totally transparent and this okay, apply. That's all, your things are ready. Now what I have to do, I have to right click on rad. So I'm just assigning the boundary. So right click on rad and assign boundary. It's a kind of radiation boundary. Okay, so what you have to do, just one second, you just go for like this, and then right click, then you go for assign boundary, and it's a type of radiation. Okay, so it's a rad one, so you just put okay. That's any name, just same name you can keep it. So my radiation boundary is ready. Okay, now what we have to do is we have to now set the excitation. Okay, so for exciting we have to go to the modeler, and we have to set the plane, because see now if you can just take the rotation or like that. So rotation button means you can rotate your part. Okay, like this you can rotate and you can see like what is happening. Okay, so like this rotation. Now see this particular part, here only we have to put the excitation. And now see the plane is not like XY plane. Now plane change. If I want to put excitation, it's a vertical type. So vertical type means now your grid plane must be in the XZ plane. See, this is your X plane, this is your Z plane. So in XZ plane only we have to set this particular excitation. So therefore now what I am doing is, now I am going for the modeler part, and in the modeler I am going to set the grid plane. Okay, so in grid plane previously it was XY plane, now I am going to set it as XZ plane. Okay, now it is set as XZ plane. Now again you go for draw, then you go again for rectangle. So again you draw the rectangle. Now you see that how the rectangle is coming. Now see the rectangle is coming as XZ plane. Okay, there you again position it properly. Minus 1.5295 comma 0 comma 0. Then what is the x size of it? So it is 3.059. And what is the y position for this? It is minus 1.6. Everything is millimeter. So now you apply and then okay. Okay, now you just see in this particular point, here only your grid, your particular excitation is set. Okay, so double click again in the particular rectangle and you just assign the name. It's a lumped port. We know that it's a lumped port for excitation. So it is like lumped underscore port. So the choice is the name you are giving just for like to make it identify. Okay, now again you choose some particular any color, and then again you give the transparency as per your choice, then okay, then apply, then okay. Okay, now my port also ready. Now what I have to do, just right click on the lump port. Okay, I've just right click on the lump port, and you go for the assignment of the port. So excitation, so you have to go for port and then go for assign excitation, and you have to select for lumped port. Okay, now see here. Here, if everything is perfectly okay, so what you'll get, like in this conductor part, H feed and ground, like two part distinctly you'll get. And sometimes somebody is doing any kind of particular mistake, means what you'll get, this particular H feed part will be missing or ground will be missing. Since still now everything is properly coming, so therefore you are getting all the part what all involved in the antenna design. Okay, so you just select the ground part, because the ground part only will be working as your supporting port. So you just select ground and then put OK. Okay, now everything is up to the mark. Now we'll go for the analysis. So you go for the HFSS and select the part like one second, you just go to the HFSS and you go for the analysis setup. Okay, then here you just go for the add solution setup. Okay, so in the add solution setup, it is like your setup 1, and you're going to solve the single frequency. And what is the exact frequency you just put here, that is 5.2 gigahertz. And how maximum number of passes and all, you just put like 15 passes, or that is your choice. And how many delta pass, how much gap you want to put between each pass, so that one you just select, that is already selected, to keep it up. And you just put it as and then you have to go for the option. Okay, in the option part you are having so many things, different things. All of the thing what you have to change is, that is the thing, like everything, like maximum number of passes, minimum number of passes, that is one. Minimum converged passes, that is also one. So ordered basis function, you see it's a zero order, first order, second order, mixed order. It's better to keep in mixed order base. Okay, and iterative solver. So iterative solver means one by one, one after that, one like that, iterative will solve. So it is an iterative solver. So then just put it OK. Okay, so all the analysis setup, the basic criteria is over. So you see, now we are coming for the right hand side, just to kick the HFSS. Now see it in the analysis part, you just created the setup 1. So now you just right click to the setup 1 and go for the add frequency sweep. Okay, so here you are having the add frequency sweep part, and in that particular add frequency sweep, so edit frequency sweep, it is there. So you just see it is interpolating type, so I keep it as it is. And linear count, you have to keep like starting and ending point. Okay, since my frequency is like 5.2 gigahertz, so we can take it from 3 to 7, or that is your choice, including the 5.2. Okay, which frequency you are just going to design the antenna with, for which frequency. Before and after some 2 to 3 values you just edit. Okay, so 3 to 7, so in between I'm having 5, but don't give much values, like here 1 to 10 was there. 1 to 10 means it will take some time, and it totally depends on your memory size. So if you're giving much amount of data, so it will have some kind of late type of issue. Okay, and here you are having how much time or point value they are asking, so you can keep as it is, or how many points in between you want to take, that one you can specify. If the number of points also, you have to have some kind of optimization. If you are giving high value, the result will come nicely, but it will have some time. So therefore some moderate value we are keeping, and then you are putting like OK. Okay, so now everything is ready. Now I am going for the validation check. So whatever design we have done, if it is proper, so it will come for the go to HFSS and validation check. See, everything I have said, design we have said it is proper, 3D model we have said that is proper, boundaries and excitation we have given, some mesh operation, analysis setup we have done, optimetrics and all we didn't set, but based on that, whatever we have said, still now radiation, everything is okay. So therefore we can go for close. So my validation, what all we have done, everything is okay. Okay, so then what you have to go now, validation is okay, so design part is proper, whatever excitation analysis I have given, everything is okay. Now go for HFSS and analyze all. Okay, so when you are starting the analyze all, it will ask you for the name, because previously we didn't give any name. So you just put here 5.2 gigahertz. Okay, so underscore antenna. Okay, or patch antenna. Now you just save it. Okay, so then and there you will save, it will start to design the part. Okay, so the design part will be started. You just see here. Okay, in this particular part, the progress bar show progress. If you're putting show progress, you can see the progress part, how the iterations and all going, how many iterations are going on, everything you can see at the bottom. So now this analysis part is going on. So it will take some time, and I told you like it will exclusively based on your system configuration. Okay, so antenna design, or if you're going more than that, like array antenna design, so these things and all totally depends on the memory criteria or your system configuration. Okay, how much your system is updated, that much soon that particular configuration part will be completed. So therefore, mostly we have done the design part. So if you are setting after this like analysis part, as I told you in the characteristic design previously, like we are having lots of different criteria, like lots of different parameters we can see. So based on that, we can design different parameters, and we can analyze the result, like properly we are getting the result or not. Okay, so now again it is like going on, just one by one frequency solver, it is just solving. So let's see when it will finish. It will just take some time. Now see 7 gigahertz is showing. So one by one frequency part is showing at the top. So now see here, it is just moving properly. So matrix part, everything is going on fine. So in the right hand side, in the meantime, if you are seeing the right hand side, so you will have all kind of setups, model, what are all the boundaries you have set, what all the excitation you have set, what are the analysis, if sometimes we need the optimetrics. Okay, so now you just see here the progress bar. Okay, so now you just see here, you just got the thing ready. So message manager, you just click there, so you'll see that your HFSS design is ready. Now see here, no error came. That no error came means perfectly see an interpolating frequency of 501 points, it is completed, and then interpolating frequency sweep, it is converged, a normal operation. So if you are having any kind of problem means you will not get this normal completion of simulation server. Okay, you will have some problem. So therefore my design is completed. Now the part is to analyze. Okay, so for analysis, what you have to go, you have to go for HFSS, and then you have to go for the results part. Okay, in that particular results, you have to go for create terminal solution data report, and in that you have to go for rectangular plot. Okay, so in this rectangular plot, you are seeing that you are having like a report for 5.2 gigahertz antenna, and it is like terminal S parameter, so dB range, so new report generation. Okay, so if you are selecting here, now you see here, you just close this part, and you just see here what is the value we are getting. So here if you are checking or right click, then you select marker, then add marker. If you are just putting the tip of the marker, then you see here 5.18 gigahertz we are getting the particular point. And what is this actually? This is nothing but you are getting the reflection loss. Okay, so that part you are getting, sorry, return loss. So that one reflection loss also you can tell. So return loss. So you know that which point, if your return loss is so minimum, so that is your convergence point. So here see, at the point of you are getting nearly minus 35 dB return loss at the point of 5.8 gigahertz. So that one shown here. So nearly it is ready. So we have optimized it for 5.2 and we are getting nearly 5.18. Or if you want to get more than optimization, so what you have to do is you have to optimize your width and length of the antenna. So based on that you can get the more precise result. And if you want to change your name, so just see here and you can go for the rename. So you can get here like return loss, RETURN, then loss. Okay, so you will have the return loss part here. Okay, so this is the graph you are seeing here, very neat and very convergence graph came. So you are having pure return loss and very TP loss you just got at 5.2 gigahertz, nearly 5.1 gigahertz. Okay, now what we can do is we can come out from this particular simulation. You can come for the desktop and we can cross here. So here is the cross if you want to come out from your particular part, I mean simulation part. Now what I have to do, I have to go for some particular polar plots and all. Then right click on the main screen and then go for the polar fields. Okay, you are having polar fields here. So for the polar fields you go for E, I mean electric field, and you go for the magnitude of the electric field. Okay, so GMS method selected. So okay. So for generating the plot, you have to select the geometry. Okay. So so next you go for the, I mean the things. So polar field. So go for E and go for magnitude. Okay. We didn't select the geometry, for that particular error came. So now you have to create the field for like 5.2 gigahertz. Okay, it is there 5.2 gigahertz. It is 0 degree. So magnitude E is already selected. Okay, so if you are just putting done, so what you will get means, see, you are just getting the electric field propagation part, and it is given like how much volt per meter it is just radiating. So you are just seeing that 2.289, and slowly if you are getting here like some light part is there, here you are getting some kind of dark part is there. So based on this particular field propagation value, you can get the radiation part. Okay, so here much radiation is not visible. Then we can go for the again for HFSS, and you can generate the report for radiation. So we can go for here radiation, and the radiation you can insert the far field and insert the far field, and you can go for the infinite sphere. Okay, so after going the infinite sphere, you just select the value. No, two values are there, one for E field, one for H field. So you just select here starting value as 0 for 5, and here you select the value as 360. So this is your 360 degree. Then you go here for minus 80 to plus 180. Okay, that is the choice of things we have to do, and then you can set it up. Okay. Okay, then again you go for the HFSS. Now we are just plotting the E and H field, okay, in the graph. Then you will identify from there also, like here I am designing 5.2 gigahertz. So in that 5.2 gigahertz, how it is like where exactly I mean it is perfectly cutting the unit circle. So there, from there also you can identify that it is a 5.2 gigahertz antenna which we have designed. Okay, so that one chart, you know, that for all antenna engineers, they know that particular chart, which is known as Smith chart. Okay, so we are going for HFSS. Then again we are going for the results. Then we are going for the create fields report, and then we will go directly for create for field reports. Okay, so we'll go for create for field reports, and we'll go directly for radiation pattern. Okay, so in this particular radiation pattern, you just can select separately theta part. So you want to select like theta and all like phi value. We are just selecting like particular phi value like 90 degree or 0 degree, like particularly something. Otherwise, it will show all these things. Okay, some select values you select, and you just select like 90 degree, and again you control and put like 0 degree if you're putting. So you will have two values. Then okay, and this is for 5.2 gigahertz, 0 and 90. Just we have selected the families, and if you are generating the new report, you can see the part here. Okay, so most, and here you can see like your values, how you're getting the gain plot. Okay, so this is one is for E field, one is for H field. So 0 degree and 90 degree parts you have got. Okay, So here also you can see this particular I mean you are having here also in this just make it. So okay, here for at 5.2 gigahertz phi value, if it is 0 degree, so you are getting the again total phi for the rate part, and one violet curve was there, that is the 90 degree for 5.2 gigahertz. Okay, so that is the thing. Other than this, if you want optometrics part, like you want to see here, I've got like 5.1 gigahertz. If based on that you want to make it perfectly 5.2 or something like that, you can come here for optometric part, and you have to set some variable and some variable range, and based on that you can optimize your antenna. So therefore the parameters like VSWR and other so many parameters are there, you can analyze. Just few parameters about I have talked, and I think for basic part this is enough, and this is the way you have to use the HFSS. And another something what I want to tell, you can create your own 3D human model, and this particular antenna you can place nearby, and you can measure the specific absorption rate and other things and all to make it to design body one antennas and all. Okay, so that is the thing what we have seen. Thank you.